Good morning, Algebra 2. Today we're going to take notes and you're going to find page 8 in your notes packet. So go ahead, why don't you pause, get out your notes. This is the big packet, find page 8 and then come back. All right, so we're talking, this is an extension of what we did last class, the few classes before. So we're talking roots, zeros, and solutions of an equation. These are all the x-intercepts. And you should be writing this down. All right. They're all x-intercepts. All of these words, roots, zeros, solutions, refer to the x-intercepts and can be used interchangeably. How do we find an x-intercept? So think to yourself, how do you find an x-intercept? All right. Hopefully you said that is when y is equal to 0. So x-intercepts of a quadratic function. So quadratics, that's what we've been graphing. So here, go ahead and sketch each of these. And then we're going to talk about them. And then one more. All right, so if we're looking at these three different graphs, right, you should be able to identify the number of x-intercepts. So the pink graph has how many x-intercepts? 2, because it's crossing the x-axis twice. So here is one of the x-intercepts, and then here is the other x-intercept. As opposed to the red curve has only one x-intercept because it only touches the x-axis once. So here is my one x-intercept. And then the black curve has no x-intercepts because it does not cross the x-axis. All right, so once you're done copying this, then go ahead and we can continue on. So again, roots, zeros, solutions, x-intercepts, they all mean the same thing. And we use this to answer questions. So here, what are the roots of this equation? So hopefully you're looking at the left-hand side and going, that looks like something that we would factor. You would be correct. So go ahead, pause the video, factor that, and then come back. All right, so when you factored, please don't drop the equals 0. If you just wrote the parentheses without the equals 0, I'm going to have to dock you half a point, even though it will pain me. So first, in both sets of parentheses should be an x, and then we needed two numbers that multiplied to the 36 and added to the 5. So that's going to be -9 and +4. And now we can set each factor equal to 0. So x minus 9 equals 0, x plus 4 equals 0. And then when you solve each of these equations, you get your roots, also known as solutions, also known as x-intercepts. So x equals 9 and x equals +4. And these are your two solutions. All right, now let's look at the next one. Now, for the next equation, hopefully you're noticing that this one is different than this top one. It's different because it is not set equal to 0. It's equal to -15. In order to solve by factoring, we have to set the equation equal to 0 before we do anything else. So we are going to add 15 to both sides. So now I have 3a squared plus 14a plus 15 equals 0. Go ahead and pause the video, factor this, and then come back to check your work. All right, so you should have factored. Make sure you didn't drop the equals 0 because a is 3. We know we have 3a and a. And then I need factors of 15. So 3 and 5, and I'm going to put the 3 over here and the 5 here, and they are all positive. If you're sitting there going, oh my goodness, I have no idea how that happened. 3a times 3 gets me 9a. 5 times a gets me 5a. And when I add those, I get my middle term of 14a. So now that we have factored, we're not done because this is an equation. It's asking us to identify the zeros. So we set each factor equal to 0. So 3a plus 5 equals 0. A plus 3 equals 0. Go ahead, pause the video, solve each of these equations, leave the first equation answer as a fraction, and then come back to check your work. All right, so you should have gotten a equals negative 5 over 3 and a equals negative 3. All right, now we're going to go ahead and look at finding the zeros of a function by rewriting the function in intercept form. So right now, if we look at our original equation, hopefully you would tell me that that is not in intercept form, that is in standard form. And now to get that from standard form into intercept form, we're going to factor. So go ahead and pause, factor, and then come back once you factor to check your work. And if you're sitting there going, I'm just going to not try it on my own and then just copy what you did, you're not going to get any better. So please take a pause and actually go ahead and factor. Thank you. So now that you've factored, you should have gotten x minus 4 and x plus 3, which means now we're in intercept form, and you can very easily tell me that the zeros are going to be positive 4 and negative 3. Once you have your zeros, then it shouldn't be too hard for you to find the axis of symmetry, right? Because the axis of symmetry is the average of the zeros. So go ahead, pause, find the average of the zeros, and then come back to check your work. All right, so now you have x equals positive 1/2. We could plug in the 1/2 and calculate the vertex, but that's, go ahead and then come back. All right. Now let's look, the y-intercept is going to be 0, comma, and then for this, it would probably be helpful if we looked at the c value, right? That's going to get us our y-intercept. So from standard form, so 0, negative 12. This parabola is opening up, right? And the domain is still going to be negative to positive infinity. All right. And so what I want you to take away here is like, now we could sketch a graph. So like, let's say this was negative 3, one of our zeros. This was 4, another 0. We know it's opening up, right? And then we can sketch, it'll end up looking something like this, maybe actually more like this, right? But that gives us kind of an idea. And then here would be my y-intercept. So I would say this was negative 12, right? And that's just giving us a picture of what the graph is looking like. All right. Now let's go ahead and scroll down and look at this next one. So to convert this into intercept form, the first thing you should always do in factoring is what? Hopefully you said find the GCF. So what is the GCF between these three terms? It would be 2. So you're going to factor out a 2. And when you do this, 6x squared divided by 2 is 3x squared. 40x divided by 2 is 20x. And 14 divided by 2 is 7. Now that we have factored out the GCF, we can go straight to 2 sets of parentheses. And now go ahead, pause and factor, and then come back. All right, so you should have had 3x and x plus 7 here, minus 1 here. Don't drop the y equals. And then go ahead and you can fill in the rest of this. So go ahead, take a pause, work through b, and then also work through the other two over here. You can fill in everything except for you don't have to find the vertex. If the axis of symmetry is a fraction, then you can kind of hold off on that for now. All right, so pause and then come back to check your. All right, now you should have worked through. Go ahead, pause the video and check your answers and then come back so that we can talk about how we would sketch a graph, even though maybe we didn't exactly find the vertex. So now let's look at B at the bottom. All right, so I can plot my zeros. So I've got negative 7, I'll put that over here. I've got a 0 there, and then I've got positive 1/3, so it's going to be pretty close to 0, 1/3. I can put that there. I know that my y-intercept is negative 14, so if that's negative 7, maybe I should make my negative 7 a little bit closer. So maybe like negative 7 is here. Negative 14 would probably be like here. And then we know it's opening up, and so that can give us kind of a decent picture of what the curve is doing, even though we didn't calculate exactly where the vertex is, right? And so that's just giving us a general idea. This is not an exact graph, it's more of a sketch, right? And then if I come over to this one, I can do something similar, right? So 2/5, that's again really close to 0, all right? And then 3, so this would be my 2/5. 3 we could put over here and say that's 3. My y-intercept is 6, so that's going to be like up near the top. And then again, we know it's opening up, and then we have to hit both of our zeros. So something of this nature, right? And this is not exact because we didn't bother calculating the y value of the vertex. Now let's look at this one. Here, we're not dealing with any weird fraction, so we can graph our vertex at -6. And then we know it's opening up. We know the y-intercept is 36, so that's going to be like way up here, right? And then -6 is also the vertex. So this is only going to have 1 0 because these are the same factor. All right. The major takeaway that I want you to have from doing this is that both our standard form, right, what we were given for each of these, and intercept form give us different pieces of information, right? Standard form is really good for finding the y-intercept. Intercept form is really good for finding the x-intercepts, the zeros, right? And once we have those different pieces of information, it makes it easier for us to graph and get an idea of what the curve is going to look like. So now let's go ahead and look at the next page. So we're on to page number 10. All right, and we're going to start with problem A. So solve by factoring. Again, I can't just start this problem. You have to set it equal to 0 first. So I'm going to subtract 40 from both sides. And now I have m squared plus 3m minus 40 equals 0. And then go ahead, pause, and factor. And while you're doing that, why don't you go ahead and work through these top 4 problems, factor them, solve them, and then come back and you. All right, now go ahead and pause the video, check, look at my work, see if you have any questions. If you do, ask someone sitting near you, and we will also go through this again next class if you have questions. All right. Please make sure that you're actually solving, right? So like for this one, to get the 2/3, you're doing 3x minus 2 equals 0. And then you're solving this equation. So you're adding 2 to both sides. And then you have 3x equals 2. And you're dividing both sides by 3. That's where the 2/3 is coming from. All right. With this one, I'm guessing that a lot of people just started factoring in this line, but what's the first thing you should always look for? Hopefully you said a GCF. Factor out that 5. It makes the factoring so much easier. And then you're just setting each factor equal to 0, and 2 repeats as a solution, so we only have to list it once. Now with this one, if you looked at this and you're like, this is only 2 terms after I get it equal to 0, you're correct. But that doesn't mean that we can't factor this. What's the first thing you should always look for? Hopefully you said a GCF. So we can take out a k, and then we're left with k minus 8 equals 0. And now I'm setting each factor equal to 0. So k equals 0 and k minus 8 equals 0. So my 2 solutions for this are k equals 0 and k equals positive 8. All right. Go ahead and maybe recap these if you have any questions, and then we're going to look at these 2 at the bottom, which I promise are not as scary as they look. So because they have a fraction, which makes this complicated, we are going to multiply by the common denominator. Maybe make yourself a note. Multiply by the common denominator. That's an A. All right, so we're multiplying by the common denominator. So here, the common denominator is 2. So I'm going to multiply every single thing by 2. So 2 times 1/2 is 1. So I get 1n squared. 2 times 3/2 n. The 2's cancel here. So I'm left with plus 3n. Then 2 times 6, because we have to distribute to everything inside of the brackets, is negative 18. And then 2 times 3 gets me 6. Now, don't you agree that because I multiplied by 2, everything by 2, it's way less work. So now okay, if you've been looking at this problem going, Miss Seamus can't multiply, you would be correct. 2 times 6 is not 18. It is 12. So this is 12 right here. Make sure you fix that, okay? Which means this is not negative 24. This is negative 18, thank goodness, because otherwise it would not have been factorable. So now we can factor this and get plus 6 and minus 3. So n equals negative 6 and positive 3. My apologies for my inability to multiply. All right, now go ahead and let's look at this one, which you should have done. You should have multiplied everything by 5. And when you did that, you should have gotten 3r squared minus 15r minus 5 equals 5 plus r. Because you multiplied every single thing by 5. All right, and then from here, now we have 3r squared minus 16r minus 10 equals 0, which is actually not factorable. So we're going to stop there for now. Eventually, we will have a way to solve that, but not at this moment. All right, but the main takeaway I want you to have from this is that you can just multiply everything by that common denominator to clear the fraction. We will go over this again next class. Please upload your notes that you took and worked through as a single PDF to earn classwork credit for today. Have a wonderful day, and I will hopefully see you on Friday.